Hey, Sunshines. So I want to go over some notes on how to prove that two triangles are congruent. So your first step is always you're given information. Most of the time that's going to be given as text. You'll have a little line that says given and it'll have some statements that you're allowed to just immediately write into your proof. But sometimes there will be things marked in your diagram that aren't necessarily stated. If you have these little arcs, that tells you that two angles are congruent. If you have little tick marks, that tells you that two segments are congruent. And if you have little arrows like this, that tells you that two sides are parallel. So it's important to look in your picture for those types of information as well. Sometimes you'll be given pieces that you need. So when you're proving two triangles congruent, you're looking for pairs of sides and pairs of angles that are congruent. But sometimes things like this will parallel lines will help you to find angles that are congruent. But be very careful about the difference between congruent segments and parallel segments. Parallel is the little arrow, congruent is just little tick marks. Now, once you've gone through everything that was given to you, you want to look for any shared sides because those are really easy to recognize. And shared sides are congruent by the reflexive property. So usually that'll show up in you'll have triangles that are a reflection of each other or a rotation of each other. But the reflexive property is the something is congruent to itself property. So you'll still have to state the name of the segment. Like if this is segment AC, then you're going to say segment AC is congruent to segment AC. For this one that's a rotation, you might want to say segment AC is congruent to segment CA. To help you keep track of which pieces are corresponding because you're actually rotating the segment around onto itself. But the key thing is to make sure that you know it's the reflexive property and remember to be careful with your spelling. That's an X. Reflexive, not reflection. Step 3 is to look for angle pairs. So what's the first angle pair that you know is always going to be congruent? So these guys are always congruent to each other, they're vertical angles. The vertical angles exist on an intersection. They're just two angles that are across from each other on the intersection of two lines. If you have a pair of parallel lines, then you get those angle pairs that we talked about last chapter. So alternate interior, corresponding, and alternate exterior are all congruent to each other. So these are some examples of what those angle pairs might look like being used in triangles. So with alternate interiors, sometimes you get these hourglass shapes. You also sometimes use parallelograms. These two angles here are alternate interior angles as well. For corresponding angles, a lot of times you'll see just two triangles next to each other along a line. Alternate exterior is much less common, but this is an example of what that could look like. And then your next step is to look for midpoints and bisectors. Usually that means you'll actually have been given the word midpoint or bisector in your given information. So if you were not given that, you're probably not going to use a midpoint or a bisector. So bisectors and midpoints cut something in half. An angle bisector cuts an angle into two congruent smaller angles. A segment bisector or a midpoint cuts a segment into two congruent smaller segments. So if you're told that something is a bisector or a midpoint, it just means you need to go find which two pieces are those halves and state segment AB is congruent to segment BC or whatever they're called. And then hopefully by that point, you have 3 pairs of congruent pieces, angles, or sides that give you one of your 5 shortcuts. Remember that your 5 shortcuts are side, 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 angle, side, angle, side, angle, 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 side, and then HL, which is the weird one where instead of being 3 pieces that you know are congruent, it's 2 pieces that are congruent and 1 right angle. So HL still has 3 pieces, but you need to be told that one of your statements is going to be that two of your angles are right angles instead of being that the two angles are congruent to each other. And that is how to prove that two triangles are congruent.